All right, so in Nancy's video, she gave you this formula for integration by parts and showed you a little bit with her Lie8 process on how to decide your U and your V. I'm going to show you why this formula is. We're going to start out with a function, and then I'm going to prove this formula for you. Then we're going to go ahead and do a few problems so that you get a chance to see them, since Nancy did not do very many. All right. So we're going to start to prove the integration by parts formula, starting with f of x equals u times v. We're going to take the derivative, but it's a product, so we're going to use the product rule. So derivative of the first, we're differentiating with respect to x, so there you go. Leave the second alone, add on, leave the first alone, and take the derivative of the second. All right, so now let's rearrange a little bit. I'm going to move this differential. I'm going to move the differential since it's in both. I'm going to multiply both sides by dx. So I really have v du plus u dv. Now I'm going to take the antiderivative of both sides of that. So derivative of an antiderivative or antiderivative of a derivative cancels, so really that's back to f of x equals, well, we're going to leave these like they are, but oops, I need my integral sign. Now on this one over here on the left hand side, we know that f of x is what we started with. F of x is uv. So I'm going to replace that, substitute it. uv equals v integral of v du plus the integral of u dv. So if I want to rearrange that a little bit by subtracting this off of both sides, you see that I'm right back to my formula. And so I have proven my formula. If my function is u times v, then my formula is in fact this guy right here. All right, so we're going to talk about this example. We're going to take the antiderivative of x cosine x dx, and we're going to use integration by parts because we do not have a way to do the product rule and use substitution. You can try it, but it's just simply not going to work. So I've written the formula over here. Nancy talked about Lie8. We're going to talk about that, but you have to pick your u and your dv, and you have to be a little strategic about that. All right, so u, we want to pick the u that is going to get less complicated, or a little more simple at least, when you take the derivative. So I'm going to pick x for my u because when I take the derivative, it's just 1 dx. We're going to need that differential. And if I take this as my u, that would be not great because it doesn't get any simpler. It's just sine, so negative sine, but it's not going to get any better. Sine isn't any better than cosine. So I'm going to choose that as my u. So that leaves cosine of x dx for my dv. All right, so du is very easy to get. It's just dx when I take the derivative. To get my v, though, we have to integrate. We have to go backwards. So I'm going to take the integral of both sides. So v equals sine, of x. All right, so we said you have to have this plus c, but you really don't need it for this. We're going to put our plus c at the end. All right, and now we can just use our formula as long as we've got everything we need. Okay, so this is our dv, this is our u. So we're going to plug it into the formula. This is our u dv, so that should equal, our integral of u dv should equal u times v, which we found over here, minus the integral of v is what we just said, sine x, du. Well, du, we said, is dx. Now that we know how to integrate, so we chose well. Going back to Nancy's little Lie8 way, we have an algebraic part and we have a trig part. So whichever one comes first in Lie8 is the one you want to use for u, and algebra comes before trig. So that's another way to talk about how to find your u. All right, so x sine of x is done. That's just part of the formula. Minus, what is the integral of sine? Well, it's negative cosine. Now, because we are taking an antiderivative, we do need the plus c. All right, because it's a family of functions. We don't have any limits, so that we're just finding the area between on one interval, we have a whole family of functions. All right, so to simplify, x sine of x plus cosine of x plus c. And there you have it. All right, so Nancy alluded to the fact that sometimes you have to use repeated use of the formula for integration by parts. So we're going to talk about that really quickly. So again, we've got x squared and e to the x. We have to decide which one is going to be our u. Well, when I take the derivative of x squared, I get 2x, so it's a little bit nicer. It's not as, it doesn't have quite the exponent, but if I take the derivative of e to the x, it's just e to the x. It's not simpler. The other way to think about that is this is algebraic, and this is exponential. So algebraic comes first, exponential is out. U has to be x squared, and the dv is our e to the x, and it needs the differential dx. All right, so du then we already said is 2x dx, and dv we integrate to get the integral, but since the integral of e to the x is just the e to the x, that's all very nice. And then we're going to plug in our formula. So our integral right here, we have integral of u dv, right? This whole thing is dv, and that's u, so we have integral of u dv. It should equal u, x squared, times v, that's e to the x, minus the integral of v, that's e to the x again, du. Well, du is 2x dx. All right, so this part in the front is, it's done. We can't do anything more to simplify it. But this, we do not know how to take the antiderivative of. We have to use integration by parts again. So we're going to start over with our lyate. Our u has to be our 2x. And our dv is going to be e to the x again. All right. So now our v is, oops, I need my dx on there. Okay. So now our v is still the same. It's the same dv as before. So integrate dv and e to the x, and you get v and e to the x. And this guy is just 2 dx. Don't forget the dx. It's very important. All right. So this first part, it's just done. We're going to do the formula on this u dv. So now our u, we said was 2x. Our v, we said is e to the x. We have to subtract the integral of our new v, which is e to the x, and du, which is 2 dx. Okay, so that's not horrible. We actually are almost done. Minus 2x e to the x. I am going to move this guy out in front so I don't have to look at it like that. So that will be a plus 2, and what's the integral of just e to the x now, since that got put out front, is just e to the x, and then plus c. So that whole integral is that. It's not that bad to do the integration by parts. It might be somewhat tedious sometimes, but really it's just using the rules we have learned already several more times.